Now that we've gotten into our unit on trigonometry, we are going to be moving away from right triangle trigonometry, and we're going to go into a section that's called Trigonometric Identities and using them in proofs. So today we are going to be talking about what the trigonometric identities are and how we can use them to simplify expressions and eventually get to using them to write proofs. So trig functions have many relationships that can be expressed as what we call identities. What that means is that some relationship between trig functions will be equal to another relationship between trig functions. Their identities, you'll notice, because they have equal signs, that means the left-hand side is identical to the right-hand side. So an identity is an equation that is true for all values of the variable or variables that are defined in the equation. So you'll notice that when we get to writing out these identities, we'll be writing it as sine of x equals this. And what it's saying is that no matter what value x is, that identity is going to still hold true. Now we can use these identities to simplify expressions and write proofs. So there are a couple of sets of identities. The first set of identities are called the quotient identities. So the quotient identities, as you might imagine, would be 1 divided by another is equal to a quotient. So here are the two. Tangent of x is equal to sine of x over cosine of x. And the second one, cotangent of x is equal to cosine of x over sine of x. Now you may remember that cotangent is the reciprocal of tangent, so you can see exactly how we get that second one. All we do is take sine over cosine and flip it, and it becomes cosine over sine. So just as an example of how we would use this identity to simplify an expression, let's take a look at example 1. So here we have, this is in terms of t instead of x, but it still works the same. So we have tangent of t times cosine of t. Now how can I simplify this down? Remember, when we're simplifying an expression, we're trying to get it down to fewer things. So right now we have it in terms of 2 things. So let's see if we can get it down to something even simpler. Now, because we know tangent of t is equal to sine of t over cosine of t, what we can do is we can replace tangent of t with sine over cosine of t. Now, how does that help? That looks like it gets more complicated. But if you look at what we have left, now we have a cosine of t in the denominator, which will cancel out with the cosine of t that was already given to us. So because that cancels out, then this is simply equal to sine of t, which is now simplified from tangent of t times cosine of t. Okay, so that's an example of how we could use a quotient identity. The second set of identities are what we call the reciprocal identities. So these involve, as you might guess, the identities sine, cosine, and tangent are going to have reciprocal identities relating to their reciprocals, cosecant, secant, and cotangent. So sine of x is equal to 1 over cosecant of x. Cosine of x is equal to 1 over secant of x. Tangent of x is equal to 1 over cotangent of x. Now, the same is true for each of their reciprocals. So cosecant of x is equal to 1 over sine of x, secant of x is equal to 1 over cosine of x, and cotangent of x is equal to 1 over tangent of x. Now here's an example of another way we can use these identities. So in example 2, you're given that sine of t is equal to 0.28 and cosine of t is equal to 0.96. And you're asked to find cosecant of t and secant of t. Now, you actually don't need to solve for t in order to figure this out. You absolutely can. I think it actually takes a little bit longer. But because you know cosecant of t is the reciprocal of sine of t, so So let's go ahead and write that down. So cosecant of t is equal to 1 over sine of t. And you're told sine of t is equal to 0.28. So we can replace that part, sine of t, with 0.28. And then go ahead and divide. 1 divided by 0.28 is about 3.57. Okay, we can do something similar with secant of t. So secant of t is equal to 1 over cosine of t. Cosine of t is 0.96. So now we do 1 divided by 0.96, which comes out to be about 1.04. Okay, the third group of identities, so the first group being quotient identities, the second group being reciprocal identities, the third group are what we call Pythagorean identities. So as the name suggests, remember the Pythagorean theorem involves a squared plus b squared equals c squared. These will be similar in that sense, where you're going to have a relationship between trigonometric functions that are being squared and added together, summing to something on the other side. So the first one is sine squared plus cosine squared equals 1. Now do note the squared being on sine means the entire thing is being squared. If we put the squared on the x, then it might look like only the x is being squared. But remember, sine on its own isn't a value itself, right? It has to be sine of something in order to get a value. So sine of x, the entire thing squared. That's what this is saying here. Sine squared x plus cosine squared x equals 1. Tan squared plus 1 is equal to secant squared. And the last one, 1 plus cotangent squared equals cosecant squared. Now note with these identities that you can, if you'd like to, move things around if it helps for you to use it in a different form to help simplify an expression down. So for example, if you take that first one, sine squared plus cosine squared equals 1, you could subtract the cosine squared if that helps. So you would have sine squared equals 1 minus cosine squared. Or you can subtract the sine squared over if that helps. So cosine squared is also equal to 1 minus sine squared. It really depends on the problem when that might be useful. For example, you might find it useful if, for example, you might end up needing to cancel out a sine squared with a minus sine squared. So you can replace the cosine squared with 1 minus sine squared. But again, it really depends on the problem that you have and how you'd be able to use the identity, perhaps in a different form. Okay, so let's take a look at example 3. Simplify the expression below. We have tan squared cosine squared plus cosine squared. Now with all of these, the more complicated they get, the more ways there are of going about simplifying the expression. But you should be able to simplify it down as much as you can in different ways, but get to the same thing. Okay, so let's start off by replacing tan squared. I want to simplify that first term, tan squared times cosine squared, and I know by a quotient identity that tan is equal to sine over cosine. So I'm going to replace, now be careful here because here it's tan squared. So if I'm replacing tan squared, I need to make sure I'm replacing it with sine squared over cosine squared. Now you can see that the cosine squareds are going to cancel, which leaves us with sine squared plus cosine squared. And from here, we can actually simplify this even further by using a Pythagorean identity, because sine squared plus cosine squared is actually exactly equal to 1. And that's it. Okay, let's do some more complex examples. All right, for example 4, we have cosecant of x plus cotangent of x in parentheses times 1 minus cosine of x. Now, probably the best thing to do if you see parentheses is to go ahead and multiply everything out. It's actually going to look a lot longer and more complicated at first, but it'll actually help us later on in terms of figuring out what we can cancel out, what we can replace, which identities we'll need to use. So let's go ahead and multiply this out. So cosecant of x minus cosecant times cosine plus cotangent minus cotangent times cosine. So let's see what we've got to work with. So I see this cosecant of x times cosine of x. I want to see if there's anything I can do to simplify this down to be fewer things. So I know that there's a reciprocal identity, so I can replace cosecant of x with 1 over sine of x. And that doesn't cancel out, but if we were to multiply that together, we end up with what? Cosine of x over sine of x, which, by quotient identity, is equal to cotangent of x. Okay, that might be getting us somewhere. So now, if you look at what we have left, now everything's in terms of cotangent. We have a minus cotangent of x, and we have a plus cotangent of x, and those are going to cancel. Great, so now we've simplified it down a bit more. Now another strategy is to try to get everything in terms of just cosine and sine. Eventually you should be able to get everything in terms of cosine and sine. By reciprocal identities, by quotient identities, you should be able to break it down some more. So, let's see. Cotangent is equal to cosine over sine. And now, cosecant we can write as 1 over sine. So now we have everything just in terms of sine and cosine. Okay, I know it's still looking pretty complicated, but we're almost there. So we'll go on to the next slide here. I'm just going to recopy this last line here. And now look, we actually have the same denominator. So with the same denominator, that means I can actually subtract those two fractions. So it becomes just one fraction. So now I have 1 minus cosine squared all over sine of x. Okay, another clue or another hint when it comes to these problems is if you see a 1 or if you see something being squared, you might want to see if a Pythagorean identity will be helpful. So in this case, the 1 minus cosine squared should ring bells that, well, I have a Pythagorean identity that I can use here. So the identity we'll use here is that sine squared plus cosine squared is equal to 1. So what I'm going to do is I'm going to replace the 1 with sine squared plus cosine squared. Okay, so that becomes sine squared plus cosine squared, and then we'll also add in the minus cosine squared that was there. And now you can see the cosine squareds are going to cancel. And look at that, we're just left with sine squared over sine, and sine squared over sine, one of the signs will cancel from the numerator and the denominator, which leaves us with sine of x. So something that looked very complicated at first, we were able to simplify it down. We used steps like trying to get things all in terms of just sine and cosine. We tried to see if there were things we could cancel out. But in general, with a lot of these problems, it's going to take a little bit of guessing and checking and just getting used to trying these out. The more familiar you are with the identities, the better you'll get at trying to simplify an expression like this. Okay, we'll look at the last example. We have sine of x plus cosine of x in parentheses times sine of x minus cosine of x in parentheses plus 2 cosine squared. Okay, again, if you see parentheses, I would go ahead and start multiplying it out. So multiply that out, we have sine squared minus sine times cosine plus sine times cosine minus cosine squared plus 2 cosine squared. Okay, what's nice is right away we see the minus sine cosine plus sine cosine canceling out right away. Okay, that leaves us with sine squared minus cosine squared plus 2 cosine squared. And now we have some cosine squareds. They are like terms, so we can go ahead and add those together. That leaves us with sine squared plus cosine squared. And now, hopefully, this has become a little bit more familiar to you, but that should start to jog your memory of, oh, it's a function squared plus another function squared. Let's look and see if there's a Pythagorean identity that works with that. And in fact, sine squared plus cosine squared is equal to 1.